Hello students. So let's continue the problems on areas related to circles. So the 10th question, the area of an equilateral triangle ABC is 1732.0.5 centimeter square. So they have given us the area of the equilateral triangle. Let's write it down. So area of equilateral triangle ABC. Equilateral triangle ABC, that is given as 1732.0.5 centimeter square. With each vertex of the triangle as center, a circle is drawn with radius equal to the half the length of the side of the triangle. Find the area of the shaded region. Okay, here we have to find the area of the shaded region. Now, to find the area of the shaded region, what we'll do is we will take the area of the equilateral triangle, that is this complete area. Okay, we get the equilateral triangle. In that, we're gonna subtract this part that is looking like a sector. Totally, there are 3 sectors. If we subtract the 3 sectors, we get the shaded region. Okay. Now, since it is a sector, we must know the angle. So here the angle is 60 degree. Here the angle is 60 degree. And here the angle is 60 degree. Okay. So the formula will become area of the shaded region. Area of shaded region is equal to area of triangle ABC minus 3 times, there are 3 sectors, so 3 times area of sectors. Okay, now area of triangle ABC is already given, which is 1732.0.5 minus 3 times area of sector is given by the formula theta by 360 into pi r square. But the problem here is we don't know the value of radius. The radius is not given, but it is given that radius is equal to half the side. Okay, radius is equal to half into side. It is given in the data. Now, but the side of the equilateral triangle is not known, right? So we have to find the side of the equilateral triangle. Only then we can find the radius. Once we find the radius, we can substitute. So for that, I'm going to use this area of triangle ABC is given as how much? 1732.0.5, isn't it? We know that area of an equilateral triangle is given by the formula √3/4 into side square. Okay, that will be equal to 1732.5. Now here let's substitute the value of √3. √3 is given as 1.73205 divided by 4 into side square is equal to 1732.5. Okay, we need side, so let's keep side square as it is. For time being, let's create some space here. Okay, let me erase this now. Later, let me rewrite it again. Okay, so this becomes side square is equal to 1732.5 into 4 divided by 1.73205. Okay, now let me shift the decimal. 1, 2, 3, 4. If I shift the decimal 4 times, okay, so it becomes like this. Whatever you have in the numerator, the same thing you will have it in the denominator. Since I have shifted 4 times, I have to put 4 zeros in the numerator. Okay, so this and this gets cancelled. So we are left with 4 followed by 4 zeros. Now side square is equal to so much. Therefore, side is equal to square root of this. Okay, so if I take the square root of 4 is 2, and there are 4 zeros. Whenever we take square root, we take half of the zeros. That is, it will become 200. Okay, so side is equal to 200 centimeters. Okay, that's the side. So area of the equilateral triangle was given. So using that, we found the side of the equilateral triangle. If side is 100, therefore the radius becomes what? Half of the side, right? Radius is half of the side. So radius is half of 200. Half of 200 is 100. So radius is 100 centimeters. So let's find the area. Let's rewrite the formula. So area of triangle ABC minus 3 times area of sector. Now area of triangle ABC, as we know, it is 17320.5 centimeter square minus 3 into area of sector is theta by 360 degrees into pi r square. Now that will be equal to 17320.5 minus 3 into theta is 60 degrees by 360. Pi value is given as 3.14 in the question. So and r value is 100. So 100 square. So here 0 gets cancelled. 6 ones are 6 6 are 3 ones are 3 twos are. So we are left with 17320.5 minus 1 by 2 into 3.14 into 100 square. That becomes 10,000. And we can cancel it 2 ones are 2, 1.57. Okay. That becomes 17320.5 minus, we get 1.57 into 10,000. So it becomes 15700. Okay. So on subtracting this, we get 0.520 and 1620.5. 17,320.5 minus 15,700. 1620.5 centimeter square. So that's the area of the shaded region. So let's get into the next question. The next question: on a square handkerchief, 9 circular design, each of radius 7 centimeter, are made. Find the area of the remaining portion of the handkerchief. Remaining portion is this portion where you got all these portions, right? This is the remaining portion, and it's very clearly area of the design or the area of the remaining portion. Area of the remaining portion, that will be actually equal to, let's find the area of the square. In that, let's minus the circles. Okay, the 9 designs are not required. So 9 times area of circle, isn't it? Let's find the entire area of the square. In that, we don't need the designs area, so let's subtract it. Okay, area of square is given as side into side minus 9 times area of circle is pi r square. Now the side of the square is not given, but it is indirectly given. See here, if you observe, there are 3 circles. Let me draw the figure again. Okay. Okay. Now the diameter of the first circle plus the diameter of the second circle plus the diameter of the third circle, that will be actually equal to the side of the square, right? Let's say this is AB. Okay. This is the complete figure. I've just taken the top 3 circles. Okay, forget about the bottom. And if you observe the diameter of the first circle, diameter of the second, diameter of the third, that will be actually equal to AB, right? So the side of the square, let me write it here. Side of the square is actually equal to 3 diameters, 3 into diameter of the circle, isn't it? So 3 into diameter becomes how much? The radius is 7, therefore the diameter is 14. So 14 3s are 42 centimeter. That's the side of the square. So let's substitute here. So side into side, 42 into 42 minus 42 into 42 minus 9. Pi value is 22 by 7. R is 7 square. So 7 into 7. So 7 7 gets cancelled. 42 into 42. So if you multiply 42 into 42, 2 2s are 4, 4 2s are 2 4s are 8, 4 2s are 8, 4 4s are 16. So we get 1764. 42 into 42 is 1764 minus 9 into 22 into 7. 22 into 7 is 154. 154 into 9. So 9 4s are 36. 5s are 48 plus 3, 40, 45 plus 3, 48. 9 ones are 9. 9 plus 4 is 13. So we get 1386. Okay. Subtracting these two things, we get the required answer. So 14 minus 6 is 8. 15 minus 8 is 7. 16 minus 3 is 3. So it becomes 378. So the required answer is 378 centimeter square. Let's get into the next question. So in this question, the area of the shaded region must be found. And if you observe carefully, the area of the shaded region is actually equal to the area of the quadrant. Okay, clearly they have mentioned OACB is a quadrant of the circle. So let's find the quadrant of the circle, area of the quadrant. In that, the triangle OBD area is not required. Okay, so the formula will become area of the shaded region is area of the quadrant minus area of the triangle. So any of the first sub question is area of quadrant. Let's find that. Area of quadrant. Area of quadrant is equal to 1 by 4 pi r square. So 1 by 4, pi value is 22 by 7, and the radius of the quadrant is given as 3.5. So it becomes 3.5 into 3.5. So let's cancel 7 ones are 7, 0.5s are. So it becomes 1 by 4 into 22 into 0.5 into 3.5. So here we can cancel 2 2s are 2, 11s are. So it becomes 11 by 2 into 0.5 into 3.5. So 11 by 2, actually we can write it as 5.5. 5.5 into 0.5 into 3.5. So let's multiply all the stuff. 5.5 into 0.5 into 3.5. So we get it as 9.625. Okay, if you multiply all this, you get 9.625 so much centimeter square. The next question, area of the shaded region, the second sub question, area of shaded region. Area of shaded region is actually equal to area of quadrant. Area of quadrant minus area of triangle OBD. Okay. Now area of quadrant, we have already found it as 9.625. So minus area of triangle, let's use half into base into height. Okay. Half into B into H. Now 9.625 minus half. Let's take OB as the base. Let's take OB as the base. This is the perpendicular because it's a quadrant, right? The angle is 90 degree. OD will become the height. Okay. So OB is the base and OD is the height. So 9.625 minus half. OB value. OB is basically the radius, right? So OB is 3.5 and OD is given in the question as 2 centimeter. So 2 gets cancelled. So it is actually 9.625 minus 3.5. On subtracting it, we get it as 6.125. That will be the final answer. Okay, 6.125 centimeter square. That's the area of the shaded region. Let's get into the next one. In the next question, a square OABC is inscribed in a quadrant OPBQ. So OPBQ is a quadrant. Okay. OA is equal to 20 centimeter. So OA value, this value is equal to 20 centimeter. Now what we have to find this area of the shaded region. So the area of the shaded region, the formula will become area of shaded region is actually equal to, let's find the area of the quadrant. In that, what is required, what is not required? The square OABC. The square is not required. Okay. So area of quadrant minus area of square OABC, which is not required. Now area of quadrant is given by the formula 1 by 4 pi r square, and the area of square is given by side square or side into side. Now they have given the radius of the circle. Radius of the circle, sorry, they have given the side of the square, which is 20 centimeter, but they have not given the radius of the square. Now how do we find the radius of the square? If you observe the figure properly, OB is actually the diagonal of the square, isn't it? Let me draw it properly. OB is actually the diagonal of the square, but OB is also the radius of the square. Okay, what is radius? It is the line from the center to any point on the circle, right? So O is the center. So B is any point on the circumference. So if you join OB, that's actually radius. It is also the diagonal of the square. Okay. Now remember, diagonal of the square is given by the formula side into root 2. Let me write it here. OA is equal to 20 centimeter. That is the side of the square. And diagonal of the square, diagonal will be equal to side into root 2. Here side is 20. So 20 root 2, that is diagonal. The diagonal of the square is actually equal to radius. Okay, because the radius and the diagonal are the same thing here. So we got the value of radius. So 1 by 4, pi value is 3.14 into r square. R is 20 root 2, the whole square, minus side square. Side is what? 20. So 20 square. So let's simplify this. 1 by 4, 3.14 into 20 square is 400. Root 2 square is 2. Minus again 20 square is 400. So here we can cancel 4 ones are 400s are. So we'll be left with 3.14 into 100 into 2 minus 400. So 3.14 into 100 becomes 314 into 2 minus 400. So 314 into 2 is 628. 628 minus 400. So 628 minus 400 becomes 228 centimeters square. That's the area of the shaded region. Let's get into the next question. So in the next question, this is actually a similar question which we have already done it. So basically we have got two sectors here. Okay, one is ABOA. Start from A and end up at A, or you can start from O. Okay, this bigger one, OBAO. This is a bigger sector. Inside that we have got a smaller sector. So bigger sector minus smaller sector gives us the answer. Okay, so area of shaded region, AOSR, area of shaded region is equal to area of big sector. Area of sector, what is the name of the big sector? OABO minus area of sector OCDO. Okay, now area of bigger sector, theta by 360 degree into pi, bigger sector, so bigger r, minus theta by 360 degree pi smaller r square. So here we can take theta by 360 degree into pi as common. So we'll be left with capital R square minus small r square. So theta value, as it is given in the question, it is 30 degree. 30 degree by 360 degree into pi value is 22 by 7. Capital R from the figure, it is 21. So 21 square minus small r is 7 square. So here we can use a square minus b square. So 30 degrees by 360 degrees into 22 by 7. A square minus b square is a plus b, a minus b. So 21 plus 7 is 28. 21 into a plus b, a minus b. 21 minus 7 is 14. So here we can cancel 7 ones are 7, 4s are 0, 0 gets cancelled. 3 1s are 3, 12s are. So 4 1s are again 4, 3s are. So we are left with 22 into 14 divided by 3. So 22 into 14. 14 2s are 28. 14 2s are 28. So it becomes 308. So it is 308 by 3 centimeter square. Okay, a very easy one. Let's get into the next question. So here we have to find the shaded region. Okay, ABC is actually a quadrant. It is given in the question, and a semicircle is drawn with BC as the diameter. Okay, taking this line as the diameter, we have drawn a semicircle. Okay, find the area of the shaded region. Okay, now the semicircle is the biggest semicircle that you can see here. This is the semicircle that is drawn. Okay, now how to find the area of the shaded region? It's very easy. Now if you observe carefully, this triangle, actually this quadrant, okay, what I've shaded in yellow color is the quadrant area of the quadrant. Okay, now in this area of the quadrant, if I subtract the triangle, okay, let's say I'm subtracting the triangle. Okay, so then we get only this much, isn't it? If you subtract the triangle, we get only this much. Now this complete thing is a semicircle. In that semicircle, if we subtract this part, we'll get the answer. Okay, so area of shaded region, or you can also take this as region 1, this as the triangle as region 1, and this as 2, and this as 3. Okay, the required region as 3. Okay, now if you observe carefully, 2 plus 3, the region 2 plus 3 is actually equal to semicircle, isn't it? If you add this region 2, 2 is this shaded region, this region and the blue color shaded region, if you add both, that is actually equal to semicircle, isn't it? Now 1 plus 2 is what? 1 plus 2 is quadrant. So here we have got 2 plus 3 is equal to semicircle. Now what we are going to do is, we are going to find the area of the quadrant. Area of the quadrant, 1 plus 2 is actually quadrant. Okay, in that quadrant area, what we are going to do is, we are going to subtract 1. Okay, so if you subtract 1, you get only 2. Okay, so quadrant is this complete thing. In that complete thing, if I subtract the triangle, I'll get the region 2. Now in this complete semicircle, if I subtract the region 2, I get region 3. Okay, that's the logic that we are going to apply. So therefore, the final formula will become area of shaded region. Area of shaded region is area of quadrant minus, or let's do it like this, area of semicircle area of quadrant minus area of triangle ABC. Okay, if you remove the bracket, area of semicircle minus area of quadrant plus area of triangle ABC. Okay, now why we have put a bracket is, as I told you, See, region 1, 2, 3. 2 plus 3 is what? Semicircle, right? 2 plus 3 is semicircle. In that semicircle, what is not required? 2 is not required. Now, how do you eliminate 2? So, for that, what we'll do is we have to find this 2 first. How do we find this 2? Area of the quadrant minus 1. That is the triangle. Okay. So, that's why. So, area of the semicircle minus the region 2. How do we find the region 2? The region 2 is found using the formula area of quadrant minus area of triangle ABC. Okay. So that's the logic we have applied here. The area of semicircle is half pi r square. I'll take it as capital R because there are two circles. One is the quadrant, another one is the semicircle. So I'll take capital R for semicircle minus 1 by 4 pi small r square plus the triangle formula will be half into base into height. So let's substitute half. Pi value is 22 by 7. Okay. Now R, this capital R is the radius of the semicircle, but they have given BC is the diameter of the semicircle. So BC value is not given directly, it is given indirectly. Okay. AC is the diameter, AC is the smaller radius. So this is 14. This is 14. If you use Pythagoras theorem, we get 14 root 2. That's the diameter. Okay, length. Therefore, the capital R will become 7 root 2 centimeters. Okay. And the smaller r is actually 14 centimeters. So 7 root 2 the whole square minus 1 by 4. Pi values again 22 by 7. R is 14. So 14 into 14 minus half into base into height. Base is 14. Height is also 14. Because AC is the base and AB is the height. Okay, because here the angle is 90 degrees. Let's simplify this. 2 1s are 2 11s are. So it becomes 11 by 7. 11 by 7 into 7 root 2 the whole square. 7 square is 49. Root 2 square is 2. Minus 2 2s are 2 11s are. 2 1s are 2 7s are. 7 and 7 again gets cancelled. So here we are left with 11 into 14 minus 2 1s are 2 7s are. We are left with 7 into 14. Okay, so here we can cancel 7 1s are 7 7s are. So 11 into 7 is 77. 77 into 2 is 154. So 154 minus 11 into 14. 11 into 14 is also, okay, this is actually plus. 154 minus 154 and 7 into 14 or 14 sevens are 98, isn't it? So here, as you can see, plus 154 minus 154 gets cancelled. So we're left with 98 centimeters square. That's the required region. So let's get into the last question of the exercise. In the last question, we have to find the area of the shaded region. So here what we'll do is, let's reconstruct this figure. Let's say we have got a square, okay, and inside this we have got a design. Let's take only the upper part of the design like this. Okay, the design is looking actually something like this, isn't it? Now I've just erased the bottom part. Okay, now if you observe, this part which I'm shading now is actually looking like a quadrant, isn't it? Now I'm sorry, let me undo it. Okay, now in this design part, let me draw a line exactly in between, which divides the design into two equal parts. Okay, so this is the first part and this is the second part. Okay, now this is the design that we have to area of the design that we have to find. So what we are going to do here is, we have constructed a line here, right? Now let's find this area. Okay, let me show it in the figure itself using different color. So first, initially what we are going to do is we're going to draw a line in between like this. Then we are going to find this area, which I'm shading in yellow color. Okay, that can actually be found using this formula. Okay, the formula will be area of quadrant. Okay, this entire thing is a quadrant. In that, the bottom part is a triangle, which is not required. Okay, so area of shaded region, is actually equal to area of quadrant minus area of triangle. Okay, area of triangle. But actually we have found only the one part, right? To find the other part, we have to just double it, because both are equal, isn't it? So let's double it. So 2 times area of quadrant is 1 by 4 pi r square minus area of triangle is half into base into height. Okay, so 2 times 1 by 4, pi values 22 by 7, and the radius is given as 8 centimeter. So 8 square minus half, the base is 8 centimeter. Okay, this acts as the base and this will be the height. Okay, so height is also 8 centimeter. So let's get into the calculation. So it becomes 2 into 1 by 4. Here you can cancel 2 2s are 2 11s are. So 1 by 2 into 11 by 7 into 64 minus 2 1s are 2 4s are 8 4s are 32. So this becomes 2 as it is. Here you cancel 2 1s are 2 8s are. So it becomes 88 by 7 minus 32. So 88 by 7, it becomes 7 ones are 7, 1 carry, it becomes 18, 7 twos are 14.5. So 5 7. So let's round it off to 5 8 minus 32. Okay, but we are getting, okay, we have, I have done a small mistake. It's not 2 8s are, 2 32s are, right? So 32 into 11, that becomes 352. So it is 50 point something, 50.2, oh sorry, 50.02 something. Okay, this comes roundly around 18 into 2 is roundly around approximately 36 point something. Okay, let's calculate it properly. 352 divided by 7, 50.28, we get it as 50.28. 50.28 minus 32 and multiplied by 2, we get 36.57. That is the required area. So this problem seems a bit tricky, but it's very easy actually. What we have done is we have drawn a line in between the design. Okay, that is we have divided the design into 2 equal parts by drawing the diagonal of the square or by drawing a line in between the design. So to find the first upper part, okay, it is area of the quadrant minus area of the triangle. To find the other design, we have to use the same logic. So area of the quadrant minus area of the triangle. So 2 times we are going to do it. So that's why in the starting itself, we have taken it as 2 times. Okay. With this, we have completed areas related to circle. In the next video, we'll come up with a new chapter. Thank you, students.